Hello everyone, I'm Hüda Yusfi and welcome to my research paper presentation entitled HASSO, Highly Automated Source Selection and Ordering System Based on Data Quality Factors. Without any further ado, let me begin. So why did we decide to work on this particular topic? First of all, to answer the user query, the system often queries numerous data sources. The answer returned to the user depends on both the data sources and the order in which they are queried. In order to obtain a complete and accurate answer, the system should select data sources that contain answers to the user query. Different data sources may contain similar answers and often don't include complete answers. Typically, a query answering process can't query all selected data sources and process all answers simultaneously, but rather it deals with a few data sources at a time and returns answers progressively. In order to obtain as many answers as possible right after querying few data sources, the system has to define a source ordering approach. Therefore, we decided to introduce a new source selection and ordering approach based on data quality factors that we like to call HASSO. So here is the agenda for this presentation. First, I'm gonna start with a literature review. Then I'm gonna present our approach for source selection and ordering data sources. Then I'm gonna move to the evaluation. Finally, I'm going to conclude this paper and present possible future research directions. So why do we need a new source selection and ordering approach? Aren't current approaches successful enough? To answer this question, let's review the state-of-the-art source selection and ordering approaches. So for example, if we take GRASP, it's a source selection approach. It checks for data accuracy, data consistency, and data coverage. These three only. We take, for example, source site. It's a source selection approach. It checks merely for data accuracy, domain accuracy, data accuracy, and data coverage. Let's take another one, sorcery. It's a source selection approach again, and it checks solely for domain accuracy, data consistency, data coverage, and data overlap. Finally, if we take, for example, OASIS, it's a source ordering approach, and it checks only for data coverage and data overlap. So what we notice here is that these available approaches don't necessarily and don't combine techniques for source selection and source ordering. They either provide techniques for source selection or source ordering, but never both or both together. Also, they don't check for all of these together, but only a few of them. So next, I'm gonna present our approach for source selection and source ordering. So our approach is called HASSO. It's a highly automated source selection and ordering system based on data quality factors. And it goes like this. Given a user query queue, HASSO selects data sources that contain a complete or part of the answer. Then it orders them in terms of their data overlap and in the decreasing order of their data coverage. Let's explain this in more detail. At first, we're gonna start with source selection. So in order for HASSO to select the appropriate data sources for a given query, it checks and verifies domain similarity and source accuracy and consistency. Well, the domain similarity uses the matches between the global schema and the data source schema to see whether they represent the same domain or not. In what case the data source is selected, okay? So to check the domain similarity for a particular source, we use this measure. Then we have source accuracy and consistency. Second measure verifies if the data sources of the same domain are consistent and accurate or not. For that purpose, we use this measure. So now the HASSO determined and selected data sources based on both their domain similarity and source accuracy and consistency. We're gonna move to the next phase, which is source ordering. So here, HASSO first is gonna order the selected data sources in terms of their schema coverage, okay, which is calculated as follows. Then it's gonna order the result or the output in terms of their data coverage using this measure. And finally, it's gonna order the result using data overlap based on this measure, okay? So that's it. So that's it for source ordering. Okay, so now we're gonna move to the evaluation section. Okay, so we're gonna evaluate HASSO onto data sets, book and flight available publicly online. For some details about these two data sets. Sorry. So the here we display the recall of sources on both data sets on the flight domain and the book domain. The findings indicate that the recall increases at different rates for the selected data sources and flattens for the unselected data sources, as we see here. So it flattens in here for unselected data sources and here also. So different rates of increase are due to the fact that source selection systems spend more execution time on high accurate and consistent data sources compared to sources with medium or low accuracy and consistency. So this is the explanation for that. Here we show the results of scalability of source selection on the flight dataset, and the book dataset. So the findings indicate quite similar changes of the execution time for different systems. The execution time increases slowly, even drops sometimes. For example, in here and here, here also, etc. Here also, here, etc. Drops sometimes for the first sources and then increases significantly for the rest of the sources. This is due to the fact that systems such with sources with low recall spend very important amount of time on high recall data sources. We also observe based on these results that HASSO is the fastest compared to other systems, Sorcery, SourceSight, and Grasp. Okay. So here we're gonna move, now that we evaluated HASSO in terms of source selection, now we're gonna evaluate it in terms of source ordering. So we're gonna compare it obviously to the state-of-the-art source ordering systems. So we're gonna start with the percentage of complete answers. We're gonna see which one like provides a huge or a bigger percentage of complete answers. So the results show that HASSO obtains complete answers more quickly. This is very important compared to OASIS HASSO, which means that HASSO obtains, or in other words, HASSO obtains 80% complete answers after querying merely 24 data sources from flight and obtains 80% complete answers after querying only 347 from the book dataset, while OASIS obtains 80% complete answers after querying 33 data sources from the flight dataset and obtains 80% complete answers after querying 501 data sources from the book dataset. How do we explain this? First, HASSO queries overlapping data sources in a decreasing order of their overall coverage, while OASIS SIS queries data sources in a decreasing order of their data coverage. So this is very important. Second, there are some records that include empty values, and since OASIS queries data sources without consideration of completeness, chance is to query more sources to return a high percentage of complete answers. So that's it for the complete answers. Now we're gonna move to another criteria, which is scalability of source ordering. So here are the results, okay? Scalability of source ordering in the flight dataset and the book dataset. So the findings or the results indicate that the execution time for both systems increases in a linear manner, okay? The findings show a very slight difference between HASSO and OSIS. Very slight difference. Now that we presented our system, we evaluated. Now we're going to move to the conclusion. So here we have demonstrated that selecting and ordering data sources relevant to a user query is very important for providing as many complete, consistent, accurate, and non-redundant answers as possible right after querying few data sources. Current source selection and ordering algorithms now examine the completeness of the answers and consider only a small collection of data quality factors. Thus, we have developed HASSO, highly automated source selection and ordering system based on multiple data quality factors. As future research directions, we suggest working on improving the data overlap verification process and also dealing with mistakes caused by data integration models such as entity resolution models, schema mapping models, and others. So that's it for our presentation for our paper HASSO, highly automated source selection and ordering system based on data quality factors. So thank you for your attention and let's answer your questions.